Today we're going more in deep into sending USB requests from the kernel module. Specifically, I will add a callback for when the request is completed. Well, that sounds simple. In order to do that, I will have to dig a little bit into the process of sending requests. The thing is, Linux uses a structure called USB request block to manage the requests. It contains information about the request, such as endpoint number, the device ID, pointer to the buffer that will be sent, and the callback. The lifetime cycle for this structure is quite simple, at least in this case. We have to allocate this request block, fill it with information it needs, and send it to some lower level that will do actual data transmission. Conveniently, the kernel API provides functions called fill URB and send URB that do, well, what it seems they do. So all I will do in this video is I will create a callback for when the request is completed, create a USB request block, pass it information it needs to transmit a message, and send it out. Simple. But there are a few technical details we need to discuss. First, where I take the code from. The function that I've used before, the sendInt MSG, already does create a URB and sends it, so I'll borrow some code from it. One thing I didn't emphasize in the coding section is that the process is similar for interrupt and bulk messages. In the coding section, I'm using the function for sending bulk requests as reference. Second, we won't need to send a request at the moment when the device file is read. I will start porting the device as soon as it is attached, so the code will migrate a little bit. And finally, the kernel log command, the message. It has a useful flag W, which makes it update in real time, useful when working with interrupts. Now that's everything I wanted to tell about. We're ready to move on to the coding. Okay, this code was kind of experimental, I will remove it. Instead, I will add the callback to be called when the device has responded to interrupt request. In this function, I will print out that it has happened and the first byte of the received data, which contains the state of the button. Now I need to start polling the device. I will be using slightly different method because the one I've used before doesn't utilize a callback. It just blocks execution until the device has responded. I'm about to take apart this function I've used before, integrate my callback in there and call it from my code. So let's take a look at it. It creates something called USB request block, or URB for short, and sends it with this USB start wait URB function. I will need to create another URB that contains my callback and use another function that, well, does not wait. Most of the code I will still borrow from this function. Before copying the code, I'll need to create variables it will be using. I'm creating a variable for pipe here and proceed to copying the code for creating a URB. After it is created, I'll need to initialize the pipe. It will be a receive interrupt pipe using the device I use everywhere, and endpoint number is 1. Next, I need to use this fill.int URB function that is supposed to initialize the URB variable. And among others, it has this blocking completion parameter. This is the callback that is called whenever URB processing is completed. I will substitute it with my custom callback. I'm verifying that I didn't misspell any parameter names, attempting to build. The compiler points me a couple of mistakes. I'm adapting the code so that it prints out error messages and I'm ready to build again. Now when doing a voiceover, realizing how impatient I was to get this thing working, but I don't want to cut out this part so that the code doesn't appear from nowhere. Anyway, I still need to actually send this request, which is currently done by this function here. I search for its definition, and right in the description it says that the function waits for the completion of the request. I suppose this function uses another function that just sends the request block. This function is relatively small, and my guess would be that this function USB submit ARP does the job, so I'll borrow it from here. I'm passing it the request block I've created and setting the memory type. I guess it allocates some memory under the hood, and I'm required to set its type. Have no idea what it should be, and probably should have used the one from the original function. It works as it is though, so it's okay for demonstration purposes. I'm building and inserting the module, opening the kernel log, this time with W parameter so that it updates in real time. Immediately I see an interrupt has happened, the device had signals that the button is not pressed. I am opening Wireshark to see how this request looks like. I see the request and the response and no errors, looking good. Now I need to make this request continuous, so I need to resubmit this URB every time it has completed. I'm doing it in the callback and rebuilding the module again. Now grabbing my device and pressing the button, the log indicates that the requests are successfully passed to the driver, so I consider this code working. And here is the video with my actual board. But still there is a problem. We can't make much use of the prints to the log. I would like to have this data appearing in my user application. I will show how to do that in the next video. See you then.